All right, let's talk about the real world of AI. Forget the lab for a second. We're going to tackle two of the absolute biggest headaches you run into when you try to take AI into production. What do you do when you need to scale for a billion people? And, maybe even scarier, what happens when your AI just stops working correctly without telling you? We're going to break down the blueprints for how to solve these massive problems.
So really think about this for a second. You've poured everything into building this amazing AI model. It works. But now the boss says, great, make it work for a billion users. Where do you even begin with that? And then there's the other nightmare scenario. Your model is out there, in the wild, doing its thing. Or so you think. But underneath, it's slowly getting dumber. Its accuracy is just degrading, silently. These aren't just thought experiments, you know? This is what keeps MLOps engineers up at night.
Okay, so here's our game plan. We'll start by really nailing down these two huge challenges. Then we'll get into the weeds of scaling for a billion users. I'm talking about the specific workflow. After that, we'll tackle that silent failure problem and look at a pretty cool drift correction loop. And we'll wrap it all up with some key blueprints you can actually use.
All right, let's dive right into section 1. We're talking about AI's two great challenges. This is all about that jump from a cool idea on a laptop to something that makes a massive impact in the real world.
So on one side, you've got this very loud, very obvious problem, scale. It's like trying to fit an ocean into a bucket. How do you process just enormous amounts of data without the whole system just crashing and burning? But then you've got the second problem, and it's much, much quieter. It's the silent killer we call model drift. Basically, the real world doesn't stand still, right? People change, trends change, and the data your model was trained on becomes history. So your amazing model slowly, quietly becomes irrelevant, and it never sends you an error message. It just gets dumber.
So, let's tackle that first beast, scale. And we're going to get super specific here. We're going to look at the challenge of fine-tuning a truly massive NLP model.
Yeah, look at that number, 1 billion, with a B. We're talking about a billion customer interactions that need to be processed. That's not just a big number, it's an absurdly big number. The amount of computing power you need for that is just, well, it's staggering.
So here's the job. You've got to take a monster of a language model, something like BERT, and fine-tune it on those billion interactions. But here's the catch, and it's a big one. A model like BERT is so huge, you literally can't fit it into the memory of one top-of-the-line GPU. It just doesn't fit. So how in the world are you supposed to train it on a dataset that big?
Well, the answer isn't one magic wand. It's a really clever automated workflow. Let's get into the solution, because this is like a 3-part recipe for handling insane scale. It's all about getting a few specialized tools to play together really, really well. Okay, first piece of the puzzle, Ray. Think of Ray as the conductor of an orchestra, or maybe the general of an army. It's the brain of the whole operation. Its entire job is to take one gigantic, impossible task, chop it up into smaller, manageable pieces, and then hand those pieces out to a whole cluster of computers, making sure everyone is working on the right thing at the right time.
Now, remember that problem where the model was too big to fit in memory? Well, that's where DeepSpeed comes in. It's like a memory magician, for real. It uses this brilliant technique that basically takes that giant model and all its training bits and pieces and shatters them into tiny little shards. Then it spreads those shards across a whole bunch of different machines, so no single machine has to hold the whole thing. Now here's the trade-off, and there's always a trade-off, right? You get a lot more network chatter between the machines to coordinate everything, but for a model this big, it's a compromise you absolutely have to make.
And here's how the whole workflow comes together. It's a beautiful thing. Step 1. Ray, our conductor, kicks off the whole distributed training job. Step 2. DeepSpeed, our magician, does its sharding trick to make the model fit. And then, Step 3, Kubernetes, which is kind of the master resource manager, keeps an eye on everything. When it sees the GPUs are getting slammed, it just automatically spins up more machines. When the load goes down, it shuts them off. What you get is this incredible, elastic, fully automated system that just scales up and down as you need it.
All right, so we've wrangled the beast of scale. But now we have to deal with the ghost in the machine, model drift. This is that sneaky problem of what happens when your perfectly good models just go bad over time.
So let's put this in a real-world context that probably hits close to home for a lot of companies. Imagine you have an AI that's supposed to predict which customers are about to churn. Cancel their service. Super important, right? But the world changes. Your marketing team launches a new campaign, a new competitor pops up, customer tastes just shift. Suddenly, the old data your model was trained on is useless. It doesn't get the new reality. So its predictions get stale, and you start losing customers, basically bleeding money.
and you have no idea why.
So, how do you fix this? Well, it's not a one-and-done kind of thing. The solution is to build an immune system for your AI, a totally automated loop that is constantly monitoring, detecting problems, and then fixing them on its own.
Okay, let's break down the pieces of this automated immune system. Think of Kafka as the nervous system. It's constantly streaming all the model's live predictions. Then you have Prometheus, which is the watchdog. It sits there watching that data stream 24/7, looking for any signs of trouble. If Prometheus sees something weird, it sounds the alarm. That alarm goes to Airflow, which is the trigger. Airflow automatically kicks off a retraining job on a platform like Vertex AI, which handles all the heavy lifting. And once the new, smarter model is ready, MLflow steps in. It's the system of record. It versions the new model, logs everything about it, and gets it ready to be safely deployed back into production. It's a full circle.
So you might be wondering, how does that watchdog, Prometheus, actually know when to sound the alarm? It's not magic, it's math. It uses a specific metric called PSI, or Population Stability Index. All you really need to know is that PSI is a number that measures how different the new data is from the old data the model was trained on. And there's a pretty standard rule of thumb. If that PSI number creeps above 0.1, that's a huge red flag. It's the system's automated way of screaming, hey, the data is shifted. This model is officially out of date.
And what's the payoff for all this work? This right here. By catching that drift early and automatically retraining, this system prevented what would have been an 8% drop in accuracy. Now, an 8% drop might not sound like a disaster, but for a critical business model like customer churn, an 8% miss could literally mean millions of dollars walking out the door. This isn't just a cool technical trick, it has a massive impact on the bottom line. Okay, so we've looked at two major problems and two really powerful solutions. Let's pull it all together and distill this down into some core blueprints for building AI that actually works and keeps working in the real world.
So here are the big takeaways. First, you've got to think beyond just deploying a model. You need to orchestrate it. Second, serving predictions isn't the end of the job. It's the beginning. You have to monitor continuously. Third, stop looking for one magic tool that does everything. The real power comes from combining specialized tools that are each great at one thing. Fourth, automate, automate, automate. If you can automate it from scaling to retraining, you should. And last but not least, versioning your models isn't optional. It is absolutely 100% essential if you want to have any hope of running a stable system.
So I'll leave you with this one final thought to noodle on. We've just designed this amazing, complex system with watchdogs and triggers to monitor our AI. But what happens when the AI that's doing the monitoring needs monitoring? It's kind of a who watches the watches problem. And it just goes to show you that building truly robust AI is never really finished. It's a constant cycle of building smarter and more resilient systems. Thanks for joining me.